Hi everybody, Steve from Steve's Makerspace, and today we are in main assembly and I am showing off this quadcopter that I built. I know it doesn't look like much, but the main focus of this is to show you the programming. So we're going to take a deep dive into programming. If you've only dabbled in main assembly, I think this is going to be helpful for you to get to the next level with programming. If you have done extensive programming in main assembly, then maybe you have something to teach me. You can leave something in the comments if you see something that I could be doing better. I've broken this video up into two parts because it was getting really long. This is part one, and you can see part two. There'll be a link. This quadcopter is definitely not perfect, but I think it's pretty good. It attempts to maintain its altitude, you can see. So you're welcome to download this from the workshop to study the programming. You might notice this video is indexed. I suggest you watch it all the way through for the first time, and then you can watch it a second time using the index. I'm going to show you the programming in stages. I've got various versions of this built. First, let's take a look at the make of the body. It's very simple. We'll start with this shape plus small, whatever that is. So let me take this and push it in, and then we'll pull this out, and we'll pull this out. That should be about 40. Go to our mechanical, powered, and the servo motor small, and we're going to stick that on there. But we want this not to be mirrored on the other side. So I'm going to point at it and hit M so that it doesn't mirror. Then we're going to stick a chassis on there. We'll make that a little wider and then extrude it to control. And we want that to be about 40. Do a motor. I started with the small motor, but I would suggest going with the medium motor. And then into the thrust, the quadcopter propeller, the small one. We can also take this middle mouse click and move it over here, like so, and another one over here. And then let's click on the servo. We're going to fix the amount of degrees that it can move. So we'll make it, I think 15 degrees is what I had. And now, finally, we'll do middle mouse click here. And that copies the entire thing. We're going to place that on this side. With a quadcopter, you don't want all the rotors rotating in the same direction, otherwise it'll cause the quadcopter to spin. So you need two of the rotors going in one direction, two of the rotors going the other direction. I think you can change the spin of the motor right in the radial menu, maybe in the flip part. But I didn't do that in my quadcopter. I used the programming to flip the spin of the motor. Probably easier to do it this way. But we definitely need to flip the rotors. So we'll click on that, E, Advanced, and flip part, and now the rotors are going in the opposite direction, and we need to do that with one of these. So now we have two rotors going in the opposite direction from the other two rotors. So now let me pull up the quad that I created when I first started this. Oh yeah, I forgot this one. So this is the gyroscope. I'm not even sure I used the gyroscope. Right, I have a gyroscope on here, but I didn't actually use it in the programming in my first iteration. And I'm realizing now that I'm going to have to turn off my face cam so you can see everything I'm doing. Hopefully this will help my frames because my computer is really having trouble keeping up. So I've got my inputs that were automatically put here, WSAD. I've also got spacebar to go up and C to come down. And left shift is going to be to start the motors going into hover mode. So I've got a toggle for that. I'm going to assume that you know some basic programming, that first that you've already gone through the tutorial in-game. But also if you need to go a little bit beyond the tutorial in-game, you should check out my video on programming, basic programming. I'll leave a link in the description. So these are my inputs, and then this is my outputs over here. So I've got my motors. Those are in parts, of course. Now this started off just as motor 1, 2, 3, 4, but you can rename these, and I renamed these front motor, rear motor, left motor, right motor, so it would be easier for me in the programming. It's easier for other people who are coming behind me to see what this all is. So let's start down here with the toggle. So with the left shift, I'm toggling on a hover mode So I've got to multiply by a constant. Now, there is in the toggle a value on, so I could have put 0.15 here, but I just wanted it to be clear on this screen how much of the full value I was using. So right now I've got 0.15 times 1, and that is being added, and eventually that goes to the motors. Then space bar is to go up, so that's being multiplied by a constant, and that's being added to this hover mode, right? Now some of these motors, because I didn't flip them in the build, I'm using a negate. The negate is under sign, so you can drag that out. So you can see if you've got a negative 0.8, that's going to convert it to a 0.8, and vice versa. I just realized that I had these switched, so I just switched them. So then I have A and D for left and right, and that is going to one of the motors, the right motor. So if I hit A, then the right motor gets more power, which is going to move me to the left. If I hit D, the right motor gets less power, that moves me to the right. I could have put opposite power to the left motor, but I found it really doesn't make much of a difference. Q and E is for rotating, and so this is turning the servos. And again, I renamed these servos. Instead of servo 1 and servo 2, I've got right servo and left servo, so you can drag out the rotate. I did increase the angular speed. It starts off at 45, I increased it to 60. And so basically you want one servo going in one direction and the other servo going in the opposite direction. And then finally my W and S, similar to the A and D, I'm taking a multiple of W and S and I'm putting it to the rear motor. So if the rear motor gets extra power from W, it's going to move forward, and if the rear motor gets less power, then it's going to move backwards. Now with this iteration, I haven't done any attempts at keeping it stable, so I'm not using the PID or PID. So let's turn it on, go up a little bit. You can see it's drifting. This works okay, but let me try going forwards, and it sort of works until it doesn't. And we'll go, let me start over, and we'll go to the left, D. Let's try A. Yeah, so it's pretty bad, but we have the start of our quadcopter. So let me pull in quad 4. This is where I'm using the, what is this? Using the gyroscope. So you can add that under sensors. Here's the gyroscope. I also put, rather than having a second gyroscope, I put a couple of 1 kilogram weights, because this is 2 kilograms. So then, in the programming, and I've tried to organize this a little bit better, pretty much everything else is the same, except I've got these PIDs in here. So before I get into the programming, let's just see how this one works. And you can see I'm going forward, it's not flipping, go backwards, go to the left. Let's go up a little bit, go to the right. So definitely not as good as my final product, but much better than the first thing I just showed you. So the PID is under state, so you drag out PID. Let me see what that looks like to start with. It starts off with a 1 here, and I mostly kept that. I did do a lot of modifications in my later iterations, but to start off I just have 1 here and 0.1 here. And where this is coming from the parts. So we go to the gyroscope and you can pull out the pitch, the roll, the yaw, and yaw speed. So this is saying take the pitch, multiply it by 0.1, and then feed that into the PID. And this one is take the roll, what is the angle of the roll, multiply that by 0.1, and feed that into this PID. And then this PID is being added to the front motor power, and this PID is being added to the right motor power. So basically this PID is taking the roll and trying to compensate with the right motor to fix the roll. And this PID is looking at the yaw speed, so the spin, and saying, okay, if it's spinning too much, let's fix that with the right servo, looks like the right servo and the left servo. So I'm multiplying the yaw speed by 3. So what is PID? PID stands for proportional, integral, and derivative. And the 3 of those are all trying to correct errors. Let's say this is your copter, it's leaning to the side, you want it to be level, so the correction system is trying to make it level. So proportional is like a strong man who says, we gotta correct this, let's give it a lot of force. And then it says, oh, we got another error, let's give it a lot of force this way. And so proportional by itself, if it's too high, it'll do a lot of wobbling. Integral is like somebody who says, you know what, I think we've been listing to the side a little bit over time. It's looking at time and it says we should apply a little bit of force right here to try to be more level. The derivative is looking at how close we are to being level and is saying, you know what, if we put too much force, we're going to overshoot and we don't want to do that. So as we get closer, let's put less force into going up. So with the proportional and the derivative together, it overshoots a little bit, but then it comes back and you got it level. So for my quadcopter, I found through trial and error that the proportional should be between 0.7 and 1, the integral should be between 0 and 0.04, and the derivative should be between 0.1 and 0.4. So that's basically it for this iteration of the quadcopter. It works pretty well. You can see it continues to drift. If I stop pressing A and D or WS or spacebar, it's drifting all over the place, and I would like to stop that drift. So let me look at quad 5. What did I do at quad 5? Quad 5 is where I added a CPU because I needed more programming and I was running out of space on here, and I didn't want to try to cram a bunch of stuff on here. You have to organize your programming. It's very important for yourself later and for other people to organize your programming. So I've added 2 things to this. It looks like I've only got 1 thing, but if I move this over, you can see there's actually 2 things I've added. This is a speedometer, so that's under sensors right here, and then under controllers, here is the CPU. And these can stack on top of each other like so. And then once you have a CPU, it's going to show up here as CPU number 1, and you can rename that CPU here. You can either rename it right here, or when you're on the docking station under parts, this was CPU number 1 and I renamed it right here to pitch and roll correction. So this renaming is also similar to the way I renamed these motors. That's going to really help you and other people to know, why do you have the CPU? What's its purpose? So you can see that I've still got the yaw PID sitting here, but the PID for pitch and roll are missing, and I've just got this pitch correction, roll correction. So if I go over to the pitch and roll correction, what I did here is I went to output and I moved that over here, and then I renamed that to pitch correction, and this is taking whatever the signal is from PID and putting it into here, and then let's just call this Bob. And if we go over to docking station number 1 and the parts pitch and roll correction, you'll see Bob here. And I can drag Bob out, and now Bob is taking the signal. So we've got a signal going into here and then coming out here. So you can see I've got the same thing happening with the pitch correction, except it's going to this pitch correction output, and then over here it's got the pitch correction input going into here. Nothing really new except that I've reorganized my programming. So that's going to do it for part 1. Before you go, like, subscribe, do all the stuff, and you can click on the link in the description for part 2. Thank you very much. Bye. Steve's Makerspace. Let's fly it forward a little bit. I'm going to hit spacebar to go up. Wow, that was bad.